Hi everyone. In today's video, we're going to see about AI periodic table. I know what you're all thinking. Periodic table is basically from chemical elements landed in order. But here I just ordered all AI components and which we say topics starting from basics and advanced. I just placed in order. So that is the thing which I call periodic table, which you can use as a roadmap to become a professional. So let's get started. So here I just categorized based on its foundation till advanced and applications at last. So you can see for the foundation, I just mentioned the known topics which I just placed in order: machine learning, deep learning, reinforcement learning, supervised learning, and unsupervised learning. Each components is very important, which you know already that you need to become some person in artificial intelligence in current world. So machine learning, and next for neural networks, which is the another basics for advanced model. So that has convolutional, recurrent, and generative adversarial network. At last we have transformer. So from this it evolved to transformer, and then the next category, which is completely different and important one, which is vision. So computer vision and object detection, image segmentation, facial recognition, optical character recognition. So each covered advanced level of image data handling. Whatever you can go with image and facial recognition models or any classification model, you need to come under work with these type of components. So each has its unique way of approaching the data. So you can use, depends on the use cases. So this is on another level. With this you can use different algorithms that we can go later. So next is to handle text data. We have NLP, LLMs, sentiment analysis, machine translation, name entity recognition. If you are looking at each component as a title, a topic, it is handled by same algorithm which we know already, but it is covered for each or specific data set. When we go under this algorithms, here we have like KNN, SVM, decision tree, random forest, k-means, clustering. So these are algorithms for unsupervised learning and classification model, which can be used for all kind of data. So these are like basic and should be known algorithms. That is why I just mentioned here, because I didn't give any linear regression or any other classification model. So here it is like covered and little advanced algorithms that you can approach with all kind of topics and components here for your use cases, like for vision models, computer visions, any object classification models. You can use any of these algorithms, and same time you can use it for NLP, I mean to handle text data you can use. So it depends on that. Ultimate goal is you're going to identify the similarity in it, so that you can actually group it and enhance every use cases depends on that. So it is all similar based on that. And at last we have this advanced algorithms, which we don't have to basically write an algorithm or code for it. You can just pull it as a component directly or import it as a component directly. So transfer learning, fine tuning, retrieval augmented generation, which is RAG, embeddings, and attention mechanisms. So this is like little bit advanced because it will directly helpful towards your results. So when you say embeddings, you can just group based on the numeric values. So just identify the text and convert that into a number. That is your score for I mean score in the sense like you can calculate the scores a similarity score based on the relatable text which is involved. So that is embeddings. And at last, we have applications like different applications which we can use, like ASR, TTS, which is text to speech, speech recognition, recommendation system, anomaly detection, time series forecast. So these are like different types of applications based on the data type. I mean, text, image, yes, the vision, and numerical data like time series for regression models. So, any kind of applications that you can use it for. So, where it comes is ML and LLM ops is at last you're going to deploy it, right? So, it comes under that. So, it is like whatever you do, you need to know all this when you build one, and at last you can just deploy it using any cloud platform. So that is how this evolution happens, and you need to know all of this, and it is very simple. All you need to cover majorly is machine learning, how it works, that understanding which will make you understand transformers, like how it is actually happening. Once you know transformers, you can directly can understand LLMs, or you can build your own LLM model. Depends on the base model that they have released. You can use any of that, and you can just fine tune it with your own set of data. So that's how this fine tuning thing can be happened. So all you need to know is this, and deep learning is just an algorithm, like how it is actually happening, forward and backward propagations. And reinforcement is something you need to know, like how to automate it completely. Uh, if you are like feeding data, how to make an model to think by itself, like giving intelligence to it. That is reinforcement learning, by giving feedbacks. Feedback learning that you can add. Whenever there is a right answer, I'm going to give a reward. If there is wrong answers, I'm just going to give a punishment or something like negative values kind of. So that's how this thing, the whole thing. So machine learning has this SL and UL, and DL has all of this. Yes, so that's how this entire thing that I just came across, and wanted to share this with you people. Let me know if I need to improvise this, or if you didn't understand the flow. Put that in a comment. I'll try to answer for your questions, or you can follow me in Discord and ask these questions directly. I'll answer. So, thank you. Thanks for watching. Bye.